moving on. How do blue blocker sunglasses work? Now, blue blockers are used by sorry. Well, take two. Here we go. See how I do this one. No? Okay. Blue blocker sunglasses used by hunters because it apparently makes things clear. Is this an illusion or is this real? This last one's good because I do the, watch this. There we go, the walk off. Alright. Blue blockers work because they get rid of chromatic aberration. By limiting the amount of color in the eye, things actually look crisper. And the reason why, we can go back to Pink Floyd, Dark Side of the Moon, they're going to tell us. Final question is, why is our vision blurry underwater? This is me scuba diving. I think this is in the Keys. I think I just said hello. Scuba diving in the Keys. I think this is an underwater worm of some sort, some kind of sea worm. I don't know why I was pulling on that. No, anyway, it made sense at the time. So the question is, why is our vision blurry underwater? Well, we're going to do a little experiment. The mammalian eye, really any eye of any creature on Earth, doesn't work well underwater. So if we float some eyes in water, they don't function right. And the reason why is because of Snell's law and light bending. For light to focus in the back of our eye and for the cornea to work as a lens, it has to have a difference in density between the cornea and whatever is outside the eye. So when you have air, which is very not dense, and water inside the eye that's very dense, it bends very well. In fact, that's why the cornea has so much power. But if you float the eyes underwater, if you open your eyes underwater, the density between the water in your eye and outside the eye is almost non-existent. So there's hardly any bending effect. And so you can almost imagine that you become 40 diopters of hyperopic underwater when you open your eyes. So, to prove this, I'm going to do a little experiment. This is a polymer that absorbs water in very high amounts. In fact, if we pour water into this polymer, this is found in baby diapers. It's neat stuff, but it expands very rapidly. Cool, huh? So, barely relevant to what we're talking about. It's a cool video. But the idea is these polymers, they absorb water at a very high amount. Wait, there we go. And in fact, this is another polymer. These are actual spheres, and they basically are filled with water. These are spheres of water, very much like the cornea in the human eye. And as you can tell, they're very powerful magnifying glasses. Look how well the light reflects off of them. Very powerful magnifying glasses. Because water and air, very different. However, if we pour water into this glass, they almost appear to disappear. They lose all of their refracting ability, their ability to work as a lens, because water and these little spheres have almost the exact same density, but practically invisible. And so that's just an example of why we can't see underwater. It's Snell's law, refraction. Okay. In conclusion, there's a lot of optics material. Hopefully you found that interesting. Now we've gone over a lot of things today. We've gone over some trauma, some of the odd traumatic things we see, some of the approach that we have for sewing up lesions. We've gone over some of the exam tricks that we can use for our challenging patients. We've gone over some interesting slit lamp pathology, which might make your own exams more interesting. And finally, we've learned some optics. Just like elephant dung makes my coffee taste better, I hope that some of this material makes your own eye exams more interesting and your own coffee taste better as well. Thank you.